Yeah.
In the calculator, I have my this calculator app on my phone that I've been using.
Oh, sure, good, no worries. All right, guys, I don't think we did this, help me out. This handout that I gave out last time from section 4142?
No.
We did not do that yet, is that right?
Yep.
Okay.
I remember it.
And now I have a calculator I can use, which is always nice. Let me see.
Oh
Oh,
yeah, we didn't fill it out.
there. There. So that's this handout. There, everybody woke up. This handout here. Let me know if you need this handout. Do, 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 do. Everybody else good around here? Don't come around here. Yeah. No, it's probability distribution.
Tired.
Yeah.
I fucked it up some before, so.
Oh, I'm glad I kept this one. Jeez.
Can I give you the test corrections for that one?
Yeah,
Sure.
yep.
What is the?
Yeah, this was, don't get too excited.
Stop buying shit.
Like the, like red?
No, warehouse.
All right, guys.
What is it?
Guys, you had your chance to ask questions about the quiz. Be quiet. So this, we talked about last time we did a few examples of this. We haven't done the other side of this yet. One thing I want to point out, we talked about this before, and this is really obvious, but it's so obvious that we forget sometimes there's two parts. What are the two things that tell me this is a valid probability distribution? All the probabilities,
Add to one.
add to one. And this one's really silly because it's so basic, but they are all between
The 0 and 1.
0 and 1. I like it.
The only other option would be to have one that is 1. And then
Yeah, and then everything else is 0, so yeah, exactly. Okay, so let's look at this side. I'm going to do this in the calculator also, just to show you. I'm going to give you this kind of problem, bless you. I'm going to give you these two things, right? These together is the full data. Are you guys with me? If there were, well, there's 1,200 kids, but like what percent of the kids said 40 years old?
13%.
13%. I love it. So we just have to be able to read the table directly, period. So I always ask a couple of questions related to that on a quiz or something, or a test, for example. So let's, before we even fill this in, let's just kind of do this. Verify this is a valid probability distribution. So why is this a valid probability distribution? Let's double check. What's got to happen? But, oh, let me say this. You ready? I'm going to say this a couple times. Get ready, guys. Holy shit, I'm going to tell you something I'm going to put on a future quiz and or test.
Oh, like the Z-score thing.
Do join. So you really should say, anytime you feel like doing a jump, I'll forgive all your weird shit. Just tell me some answers. What I'm going to do, I'm not saying it happened here.
You're really critical of yourself.
Huh? Oh. I'll give it. I'm going to give you a table where the probabilities do not add up to be 1, but they're close enough. If the probabilities add up to be 0.999, does that mean it's not valid?
No, it's valid.
It's valid, it's just rounded, right? If it adds up to be 1.001, same idea, correct? You with me? If your probability distribution the probabilities add up to be 99%, that's a smidge too big. That's 1% off, which actually is more than people think. That means you left something out. That doesn't mean you've rounded. You guys kind of with me?
Yes.
Yeah.
So I'm going to make it right on the edge. It's going to be like 0.999 or 1.001, but why do I do that? Because I'm a jack. No, because I want to make sure you're actually checking the damn shit. You don't just memorize what to say. Because the idea is you check it to make sure it's good.
Wait, 0.99999, that's pretty close.
0.999.
And you just said it was
No, 0.99.
0.9.
Like if you're 1% off, I'll bet you anything it's not just a rounding thing. I'll bet you left somebody out. Okay.
So 2 decimal places is pretty big. 4. That's pretty
Yeah. But these add up, has anybody done this for me yet?
Yeah,
What do these add up to? They
Yeah,
add
it's
up to
1.
1. Yay, all right. So the sum, you could say it in English or in Mathish, right? I always think about speak friend and enter. How do you say friend in math? I don't know. So sum, the Lord of the Rings people, fine. Or you could just say all probabilities add to 1. So you could say it in Mathish or English, yes? So 0 less than or equal to probability of x less than or equal to 1. Or you can say all probabilities between 0 and 1. I don't care. In fact, on the other side, I did the same damn thing, right? So this is a really good piece of paper to have sitting next to you as you do section 4.1 and 4.2. You guys with me?
Mm-hmm.
Okay. Gee, is that why you do these worksheets? Maybe. I don't know. So this one should be relatively easy. What do you guys think about part B here? At least 25. So what kid thinks they'll be at least 25? What ages is at least 25? 25, 40, blah, blah, blah. So you have to add all these. What's the shortcut?
Take the total and subtract 20.
1 minus 0.04. Now please let that make nothing but sense. That's exactly related to the probability of at least 1. In this case, there's no 1, 2, it's 21, 21. So the probability of everything except 21 is 1 minus the probability of 21.
Yeah.
If they all add up to 1, 1 minus one piece is the other stuff. That's just really basic computational math, right?
Yeah.
Or you just add all these up and eventually you catch up to us. So what is it? 1 minus 0.04?
0.96.
0.96. I love it. 96%. Oops, sorry, can't see. Is that all right? Either way you do it, you're fine. Just be careful if I say at least, at most. By the way, our brains hear the word, we focus on least, and we think less than, I think. But if you must be at least this tall to ride the ride, yes? If I'm there, can I ride the ride?
No.
And this is Jeff. We went to freaking Disney World. The one I wanted to ride, I was here. I was like, and then we never went back. I was like, whatever.
What you didn't know is you saved money in the long run.
That's life. They saved money. I wasn't paying any money. You kidding me? Sorry. So at least means this or more. If you could be at most 12 to eat off the kids' menu at Denny's, could I eat off the kids' menu at Denny's?
You?
No. Oh, thanks.
No.
Sorry.
But 12 or under, you could.
Total.
2 years.
So at most means this or less. You guys with me? If they could be at most so many people in an elevator. And then next one's trying to come in. Get out of here.
It's just like the greater than equal and sign.
Okay. You guys kind of with me though. It's always the translation between English and Mathish that gets weird. Right? And as some of you guys who have learned English second, you know it's not math's fault. English is freaking weird. Okay. Now we got to start doing some computational stuff. So the formula says I want to sum these up. So of course I need a bunch of these first. I'm being very nice on this worksheet. Normally I'm just going to give you this and then 2 blank columns. So you have to know what the hell to put in there. So how do I know what to put in there? Well, just cover the sum symbol. I need a bunch of xp of x's. Okay, let me make a bunch of xp of x's. So if I want to do this in the calculator, and you might want to do this with me even if you just want to do it by hand, I want to show you something really cool at the end. So let's all put in here, 21, 25, just put all this stuff in here. Scheisse. Bam. I think that's good.
Being ironic because you're using a German word but being from Finland.
Oh, sure, yeah. Well, you know, my mom, she knows so many languages, and she taught us kids none of them. Whatever. Whatever. Just
Sounds like my
English.
dad knows how to drive manual, didn't he?
Exactly, same thing for me. Alright, let's see. 2413, just want to double check. 183902. Okay, looks good. Okay. You guys all with me so far?
Yes.
So now I want L3. So you gotta go up to L3. I want to define that list. And what do I want to define that list to be?
L1 times
L1
L2.
L1, so second one times second two. L1 times L2.
Yep.
Shabam! Now you don't have to make any sound effects. Or you can choose your own. You guys, is everybody with me? And again, you don't have to do this. It's not a very long thing, but it's kind of nice to be able to do this. And if you do this, I'll show you a shortcut if you have the calculator. I don't know if I've shown you this yet or not. I just have it spit the answers out of me.
Like the sum?
No, like the answers. Like the mean and the standard deviation. Just tell it to me. Just give it to me. So let's see, what do we got so far? We got, I'm not going to write them all down. You can see them. What do I want L4 to be?
L1 times L2.
Oh, my L4 is not there. Oh, this is perfect. All right, you ready? My L4. See how my L4 is not there?
Yeah.
Man. So I go to Stat, Setup Editor, Enter, Stat, Edit. Yay! So whenever there's something weird going on with your list, just do Setup Editor. It'll bring it back to L1, L2, L3. You guys all with me? If you delete a list, ready? Delete. Oh shit! Oh shit! Why did I do that? No. So just go to Stat. I'm really sorry, guys. Go to Stat, Setup Editor. And when you go back in, not only is your list back, while your data's still there. Ooh. Okay. It's like magic. Costs enough money.
It's
better
like
do
it's a
that.
computer.
So going back to L4. What do I want L4 to be?
L1 times L2.
You could do L1, let me just show you. L1 times L3, because I need this to be x squared p of x, because, again, the formula requires the sum of these, right?
Yeah.
So of course I need a bunch of those before I can add them freaking up, right? So I need a column of these. So the way I do it, being a weird ass math dude, I do x times x p of x, and that's x squared p of x. So see the numbers I got? See them?
Mm-hmm.
Is that the same numbers you guys got? Maybe it'll come back. There it is. Now watch this. Let me clear this. If I instead do L1 squared, Jeff,
Can't see.
I'm sorry. L1 squared, right?
Mm-hmm.
That's x squared, times L2, I get the exact same answers, yes?
Okay.
Of course I do, because mathematically they both come out to be x squared p of x. So the calculator's like, whatever, human. Let me stop. All right, let me see if you guys can handle this. So let me do this the old-fashioned way first. So what do I want from these things? Like, what's the mean? How do I get the mean from these columns?
Sum
Add up which column?
L3.
L3. You guys all with me? If I add up L3, that'll be the sum of x p of x. That's what the mean is, right?
Yep.
You guys all with me? So I could do it this way. Second quit, second stat to go to list, do math, do a sum on L3. Oh my god. Okay. But let me just, everybody got that? 48.39? Let me write it down. 48.39. 48.39. Okay, I know you can't see what I'm writing down there. Who cares? Now, just watch this. If I do stat calc 2 var stats. 2 var stats, you ready? Because don't I want the sum of L3 and L4? No, Jeff. L3, there we go, buddy. L4. You guys with me? You don't have to do it this way. You can just do the list, math, sum. You guys with me? If you do it this way, you get both things at once. You just have to know what to look at. Sum of x, sum of y. Sum of x, 48.39, like we just got. Sum of y is 2673.39, which is what this sums up to be. What is that again? 2673.39. Thank you. Let me zoom out a bit. You guys all with me? So again, just to show you, if I do list, so second stat, math, sum, L4, I still get the same number I just got. Of course I do. I just got it a different way. So it's up to you. You can do it either way. I don't care. Right? Is that all right? You guys okay? Okay. So where do I put this number?
Put it in.
Does it have a place to go?
The variances. Or you're
It's
finding the
part of
variance?
the
Yeah.
formula for the variance. Yeah, this whole thing right there is this. Minus the mean squared. And of course I just gotta throw all that in the calculator. You guys still with me, alright? So again, the third column is nice. The formula for the mean is easy, which makes sense. Mean is always a lot easier than standard deviation. Standard deviation is very involved. The idea is freaky. Mean is very straightforward. So the formula for the mean is much better than the formula for the standard deviation because standard deviation is weird. So let's see what we get here.
How many decimal places did you want?
311.7979.
Does somebody know how many decimal places I want standard deviations to?
3.
That's right. So that's the variance. Variance I almost don't care about, just whatever the hell it is. And then on my calculator, I'm just going to do square root of answer. So if it's really long, I don't have to write the whole damn thing out.
Yeah.
And you don't round and make a mistake, so there. Did you guys all get 18.215?
Yep.
Okay. So the mean comes directly from the sum of this list. This list is just a piece of the equation I need to get the variance. Is that okay? Man, I do not want to play poker with any of you.
I got something very good.
It's like,
Where'd you get the 48?
Yes.
Yeah,
How
it's-
do you select this one?
oh, to do for the sum?
Yeah.
So we go through it again. So second stat, math, number 5, and then you do second 4, because all the lists are right above their corresponding numbers.
Let's see.
Second 4 is list 4. Is that cool?
Oh, okay.
Kabam! All right. Now, here's the ultimate shortcut. Not shortcut, really. It's the way to check your work, right? This is the work I got to see because I'm a math teacher. We're me. The shortcut is, can somebody remind me this is a trick question, right? I'm telling you right now, it's a trick question. Which list is my data in?
What? 3.
So if you say 1, I understand, but why is 1 not the whole picture?
Because 1 is.
What percentage of my data list is 21? What percentage of the people said 21?
4%.
4%. So list 1 and list 2 together is the data. You guys with me? Now, how many questions did I ask these people? How many questions did I ask these people? How many questions did I ask?
One.
The kids.
Ask
Thank
how
you.
old.
You made it sound like this. You know, God, just.
I never got calculators.
They asked one question, yes? How old do you think you'll be when you're Are you with me? What's related to the question in statistics? Very. So I'm going to do 1 var stats. You ready? This is the first time we're going to do this. So if I go stat, calc, 1 var stats, but we finally have a freaky list. List 2 is my frequency list. How frequently did 21 show up? 4% of the time. List 2, frequency list.
How do you?
Now, if you don't have this, if you just get 1 var stats, just do L1, comma, L2. Now you know why there's a comma on your calculator. Whole little comma key.
Wait, say that again?
So if your calculator doesn't look like this, if it just says 1 var stats, some of you guys have an older calculator, after it says 1 var stats, put list 1, comma, list 2. And you should get all this business. Does anything look familiar?
Well, you did L3.
What did I do? Did I do L3?
Yeah, your thing is L3 for
That's
X.
fine. Let me try this again. Stat, calc, 1 var stats. Thank you. That was left over from before. Yeah. So list 1, list 2. All right, now let's see if things look familiar. That's better.
Yeah.
Does everything look familiar up there?
Mm-hmm.
Mean is 48.39. The standard deviation is 18.215. Yes?
Why did, look, before you did second bar stats, now you're doing one again?
Oh, alright. The 2 var stats was because I wanted list 3 and list 4 separately. I wanted, because, and again, you never have to do that. You could just do stat, math, sum, the list. You could just do that. I just want to give people a chance to see a shortcut, yeah. Right now, I've got one set of data, but it's across 2 lists. It's got the actual numbers and it's got the frequency. Yeah. And this matches with what we got, correct? Look, this calculator now is saying, now I know it's not a sample, it's a population. Yeah.
Can you go over the variance again? I put everything in and I get a wildly different answer from you.
So you got 2673.39
Yep.
minus 48.39 squared, right?
No, because I thought to get the mean, we have to take the 48.39 and divide it by the number of numbers.
Of course not.
6.
No.
it's a population, not a sample.
No.
That's
Remember
just-
what's on the bottom
it's
of a
just a sample.
What's on the bottom of a probability? The total number of
You're good,
things.
you're good.
Yeah.
Yeah, I know it's a summation.
So it's built in. I don't have to take this and divide it again. It's already been divided.
What?
When I multiply by the probability, what is on the bottom of every probability? The total number. Do I need to divide this by the total number? It's already been done. It's in here. It's like ragu. Anybody get that now? No ragu sauce. Make your own spaghetti sauce. So this is the same formula as before, just the divided by n is built in. This is the mean formula. This is it. Once you do this, you've got the mean. Nothing else to do. You guys with me? So why don't we just add these damn things up and divide by 6 then, right? Why don't we do that?
It's already
Probability is
incorporated.
already built in.
Because if I add them all up,
Take my-
I'm assuming they all happen equally amounts of time. They all have the same frequency. Do they all have the same frequency?
No.
No. This guy's the heaviest weighted dude, right?
Mm-hmm.
That's why the mean was pulled a little bit more in this direction than down there. It came out to be almost 50, right? You guys all right? You guys with me? Okay. Does part D sound kind of familiar, but it's a little different? Well, it's the same thing. Sorry. Difference going to happen later. Part D is the same thing, except one little thing. So in the middle, I'm going to put my mean. Are you guys going to help me? If I go one step up, every step is this big.
66.605.
Sounds right. If I go one step down,
30.175.
sounds about right. Yep. Cool. Can anybody tell me which data values we catch in there?
40 and 100.
Isn't it 65 or something?
No.
Yeah, did we catch the 21s?
No.
Nope, we didn't catch the 21s. What about the 25s?
No.
Nope, that's out of here. What about the 40s?
Yeah.
Yeah, we caught all the 40s. What about the 50s?
Yes.
Yep, we caught all the 50s. What about the 65s?
Yes.
Yep, we caught all the. What about the 100s?
No.
Nope. So we caught all the people who said 40. What percentage is that already? 13%. Plus, we caught all the people that said 50. Plus, we caught all the people that said 65. You guys understand? So I would not do 1, 2, 3 out of 6. For the same reason that we have to do the mean a different way. They're not all equally likely. If I catch all the people that said 40, isn't that already 13% right there? Plus 18, plus 39. So what do you get for that?
Yeah,
67.
60.
I just said it
70.
60. No.
I love you guys. Yeah, it can't be 67.
70.
This is 31. Plus 39, 70. Yeah,
Oh, I did 15.
so I get 70%. Does everybody understand why that's a little different than before? I don't have pure numbers, I have percentages of numbers. So whatever number I catch, I see exactly what percentage I caught. And I just gotta add all the percentages for all the numbers I caught. And again, why do I do this weird thing? It's a concrete, specific example of like Chebyshev's theorem. Yes?
Can you explain how you got the 66.605?
Oh, how big is the standard deviation?
Oh, each step 18.2.
18.215. So if I take one step up from 48.39, just add it.
Okay.
Yeah, and then subtract it to go down. So now I'm within one standard deviation of the mean. And of course, chubby dude Because way out in the limb it says you caught at least nothing. Oh, thanks, Jody. Right? But this is just a more concrete. It's not a theory. This is an actual concrete. I can see what percentage I caught. All right, let me stop for a minute. How many kids believe they'll retire before age 65? We call those kids deluded. No. Who are these, by the way? Who are these
Eternally
people?
optimistic.
Who are these people right here?
Trust fund babies.
No, maybe. Maybe. What if they're not trust fund baby? Who would they be? They're going to be the next YouTube star or Twitch
influencers.
or TikToks or whatever the hell.
They're called entrepreneurs.
Can you make money on the Instagrams?
Yeah.
Probably.
You can? All right.
So much better.
Views.
You can make money on Twitter. That's true. Now you can share in the revenue. All those X now, so you don't tweet, you excrete, I guess. There's no tweets, they're excretions.
Elon Musk loves that letter.
Is what
That's
I
his
say.
thing.
I'm sorry. Everybody else is like, let's stop talking about social media. Okay, I agree.
For before 65, can we just do the shortcut again and just subtract 0.39 and 2 from 1
No.
to get a percentage?
No. Oh, yeah, to get a percentage, sure. Sorry. So, before age 65, I want to know how many kids, that's going to be the second part of this question.
Yeah, easy.
So if I know what percentage of kids said before age 65, and I know how many kids there were, I can figure out how many kids said that. So, how many kids said, the shortcut here is, isn't this 41%?
Yep.
So before 65 would be 1 minus that. What's 1 minus 0.41? 0.59. So 59% of 1,200 said that they would retire before age 65. And of course, by the time they get up there, the retirement age will probably be 70. Unless we have another recession or something in the life expectancy went down a bit. Obviously over the pandemic, but also over the recession we had in 2008.
Oh, the overall expectancy?
Yeah, the life expectancy went dipped a bit.
I looked it up. It's like 85 years old for me.
Yeah, it's insane. Especially for Anyway, all right. Anybody can do that for me? What's that?
708.
What is it, sorry?
708.
708. Okay, so 708 kids think they'll retire before age 65. Okay. That's possible. But before 30, nah, I don't know about that. Okay.
With the math.
Okay. Is that okay? So that's section 4.1 and 4.2. Right? 4.1 really focuses more on the mean, and then 4.2 adds in the standard deviation. So together they are this kind of problem.
For the homework, do you want us to make a graph? I don't know.
Yeah,
I haven't looked at it.
you're gonna make this table. Yeah, you're gonna make this table. Yeah, you gotta show me the stuff. Don't just say, I put it in the cap. No, show me. All right, so a little bit of new stuff for today, and then I'm gonna let us out a little early, if that's okay. Yeah. All right. I never know. I had somebody get angry at me because they looked them out early one time. I'm like,
They just love your class.
you'll get over it, I guess. No, I don't know. They just paid full
They feel
tuition.
cheated. I paid full tuition to be here for the full.
They wanted to torture me. All right, guys. So, we're gonna get into chapter. Actually, finish up chapter 4 first. We're probably gonna do. So we've already done 4.1, 4.2. 4.1, 4.2 are the x, p of x stuff. So please, dear God, if I give you x and p of x table, you know which formulas you're going to use. Does this make sense? You're going to use the formulas that have x's and p of x's in them, yes? Does that make sense?
Yeah.
Okay, good. All right. So let's get into 4.3. So here's what 4.3 does. No, so we were able to do this. Let's see. The probability somebody is, I'm pretty sure I've used this already, but too bad. Somebody's left-handed in America is 11%, roughly.
That was 13? Oh, that's worldwide.
The last time I looked it was 11, but maybe there's some updated stuff somewhere.
Maybe it went down.
It's been 11% forever. It's
Oh,
crazy.
I just got the wrong data.
No, you might have, we'll see. So let's say it's not right-handed. Why wouldn't I want to say just the probably right-handed instead? Because is the only two options left-handed, right-handed? Very quick side discussion.
Ambidextrous?
Ambidextrous, which means you can use either one. I would give my left arm to be ambidextrous.
Paraplegic?
One-handed.
You could have no hands, right? So, are you guys with me? There are people with no hands, okay? So I need to cover my ass for all the possibilities. So the probability left-handed is 11%. The probability of not left-handed, which covers everything, correct?
1 minus
They're
11%.
Yeah, there was a dude in Balboa Park. I loved it. He would play the guitar. He had no hands. He would play the guitar with his feet, and he was freaking. He could play a lot better than I could with my freaking hands. I tell you. It was crazy. So what's probably not left-handed? Sorry,
1 minus 11%.
which is
99 or 88%. No, 89%.
89.
okay. We'll get there. Yeah.
So here you wrote a line over L for to symbolize
Yeah, that means
not.
not.
Right. So
That's L prime.
in the
I think
test,
in the book
was it
it's got a little prime. Yeah.
Little.
That notation is stupid.
No, it's not.
It is dumb.
I just didn't know what it was. So
Huh?
I like it.
Okay.
yeah,
Because it's L
I figured it
If
out.
you've taken any calculus, prime means something very different.
Yeah.
So
What's it mean? What's it mean?
it means the slope is a good way to say it.
Oh.
The slope of a non-linear thing, so it's changing. Anyway, I'm not going to teach calculus. You
You have the
know,
wrong class that are being taught, guys.
that's fine. Okay, stay with me now. Before today, we could answer this question. What is the probability that, I pick 4 people. What's the probability that the first one is a lefty and the others aren't?
0.11.
That is an old question. We could totally do that question all day long,
0.11
right?
times 0.89.
Yeah, 0.11 times 0.89, 0.89, 0.89. Or you can just do 0.11 times 0.89 to the
You.
third power. Okay, what do you get there?
7.76.
What is it?
It's gotta be less.
0.0775.
Oh, 0.775?
75.
Okay. Roughly? Okay. You guys all with me? That's an old question. We've done that question before. In fact,
We just did
we
it.
just did it. Hopefully. Okay. So what we have not been able to do, and I think I kind of tried to lay some groundwork for this idea. What if I instead ask this question? It sounds very similar. So I got the same setup, 4 people, but now I want to know what's the probability that exactly one of them is left-handed. It's not the same question. This question is much more specific. Are you with me? This says the first one is left-handed and the 3 others aren't. How many ways could you have exactly one left-handed person out of 4?
L. Can we just do R, and then.
Let's do this.
There's so many different ways.
Let's say the probability of L, right? The probability of left-handed person, let's call that P.
Okay.
The probability of not left-handed, let's call that Q.
Okay.
Why am I doing that? I don't know. No, because that's what we use actually, to be completely honest.
So when you think not, it's Q.
If
In this
yeah, so here's the idea. In the problem, is the problem looking for left-handed people or looking for right-handed or not left-handed people? It's looking for
It's looking
left-handed
for
people.
Exactly
left-handed.
1 less.
So I call that a success. In statistics, a success is whatever I'm looking for. A success, therefore, is not necessarily happy. I could be looking for a dead body. I could be looking for a rabbit squirrel. I could be looking for whatever. You guys with me? So success just means the thing I am looking for. So little p, we call that the probability of success. And little q, remarkably enough, we call that
Probability of insuccess.
probability of failure.
Probability
Probability of success, Jeff. Probability of success. I don't know how to spell probability. It's pretty bad for me. Probability of failure. That was a failure.
Wait, that's really what it means, failure?
Yeah. Yeah. So in this case, am I saying that non-left-handed people suck? No, I'm just saying I'm not looking for non-left-handed people. So getting one would be a failure, right? Doesn't mean anything bad about them. If I'm looking for rabbit squirrels, that doesn't mean that non-rabbit squirrels are bad. They're actually really good. I like them. The rabbit ones, not so good. You guys kind of with me?
Yeah.
So success doesn't mean yay happy. It just means the thing I'm looking for. Okay. So
And that's
how many ways? Let's see. Give me one way. What's one way that I could get exactly one left-handed person? Well, we already saw one way. The first one is left-handed. That's one way I could do it, correct? So what would that look like now? Let's do this. It would be the first one's left-handed and the second one's not, the third one's not, the fourth one's not, correct?
Yeah.
Now, why did I write them all next to each other? Because what's the word separating each one?
multiplying.
Multiplying, because it's and. You guys with me?
Yeah.
Is there another way to do it?
Oh, yeah.
Or QPQQ. Or QQPQ. Now, real quick, what's that physically mean? The one I just wrote down. Just make sure you guys are all with me. That means the first two are
Failure.
not left-handed.
Oh, okay.
Third one
Left hand.
is, and the fourth one
No.
is not. So far, each one of these has exactly one left-handed person. So I don't find the probabilities. I add up everything that matches what I'm looking for, correct? And there are multiple things that match one left-handed. And what's the last one? There's one more.
QQQP.
Okay. Now math is going to laugh at us for writing all that shit down because every single one of these, what do they look like algebraically? P times Q to the third power. And how many of them are there?
4.
Aren't they all like terms?
Yeah.
PQ third plus PQ third plus PQ third plus PQ third is 4 PQ thirds. All right, let me stop for a minute. Now remember, P means left-handed person, Q means not left-handed person, right? Are you getting all this? I don't know if I trust you.
I lost where you got.
Yeah, you're good.
Okay, thanks, man.
Oh, because there's 3 per row.
There we go. There we go. You got the front row. It's not the best seat in the hospital. Is everybody still semi with me? Yes?
I just gotta fertilize it. The reason the Q is, it's Q because we're looking for 3 options in each row.
Do you agree? All right. So really quickly, you agree with each one of these, correct? There's 4 people,
Yes.
and exactly 1 is left-handed in each case, correct?
Yeah.
Mathematically, they are all P times Q to the third. You with me?
Sure.
Okay, shortcut, because we're not going to do all this shit, right? This is a derivation of an idea. There's going to be a formula. You plug stuff in, but I want you to understand the formula. The shortcut is, I want 1 success and 3 failures. What did the 4, where did that come from? Where did the 4 come from? How long the list was, right? How many ways there is to do that. Are you with me? Okay, maybe. Can you, all right, just to satisfy the urge for math, which some of you guys don't think you have it. What's the hell is this number, right? Plug stuff in. Can anybody do that for me?
3101.
3101?
Yeah.
Okay. 98707. Yeah, that makes sense. Okay, good.
What are you doing in your head?
When you do point, that's basically 0.9. You with me? 0.9 times 0.9 is 0.81 times 0.9 is 0.72 times 0.1 roughly is 0.07 times 4 is roughly 0.28. So 0.31 is close. That looks good. All right, I'm sorry. I won't take it in my head anymore unless you guys.
No, that was cool.
Your head's
But
a scary
that's
place.
again.
So cool.
I do math all the time. So if I did not pick up little things, then something's seriously wrong with me. You don't do math all the time. You're not going to pick up little things. So I'll show you little things every now. Now here's the thing. Now watch this. So the hardest part, believe it or not, the hardest part about putting together this is this number right there. You might not believe me right now because that was the easiest part of what we just did, right? But watch this. What if I had 80 people? Right? And I wanted to probably exactly 11 are lefties. Okay, you want to start making that list?
No.
You sure? P, 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 Q, 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 Q. Or it could be P, 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 Q, P, P, Q, P. Do you guys start to understand?
Yeah.
That's stupid. But mathematically, every single line I could write down, what would it look like? P to the?
11th power.
Why?
Because they're 11.
Because I want 11 successes. There were 80 people, so it'd be Q to the?
70. Or no. 69?
You guys, are you guys with me? I didn't mean for that.
And what about,
Someone got the joke.
Oh my God.
what about the
But then the number in front.
Good. That's all I asked for right now was what does each of them look like? The number in front would mean what? What would the number in front mean?
Selections.
How many would be in that list? So does everybody agree? There's no way in freaking hell you could maybe pay me enough money to make that list, but it would have to be a stupid amount of money. Is anyone curious how long that list would be?
It would be massive.
Infinite
You're not paid
amount of
hourly, your salary. So
Yeah, to answer the question, we need it, but I just want to see. It's a different question. I'm going to show you how to get the number, but I was just curious if people are interested.
Infinity
Yes.
minus.
All right,
Yeah.
200.
before I do this, have you guys ever heard
Wait,
if there was 13 topping options on a pizza? Do you know there's millions of pizzas you can
Yeah.
make?
Yeah.
Okay, you've heard that.
Mm-hmm.
This is related to this. This is kind of related to the birthday problem. We just don't know how many pairs of people we can make. And once you get over 34, there's a ton of freaking pairs of people you can make. So this, let's see how long this list is. The calculator can do this because, it costs a lot of money and its basic function is to count. Right? So here's how it does it. I love this idea. So I have 80 people, correct?
Mm-hmm.
Right.
How many do we want to choose at a time to be successes? 11. So I want to do, this is literally what this, well, it actually means combinations, but I like to use the word choose. How many ways can I choose 11 from 80? So 80, choose 11. Where does this thing sit in our calculator? I'll show you. So everybody, don't do that to your calculator. Hit 80. And then go to this, go to math. If you haven't hit that button yet, I don't understand you, because, there's a math button. What the hell could that be? Go over to probability. And do you see it?
NCR.
Yes. So don't go to National Public Radio. Go to NCR.
New California Republic.
Exactly. I was curious if it's a Fallout reference, but you beat me to it.
Oh, you know Fallout Trust Europe.
Hell yeah. April 11th.
Wait,
Right?
it says NCR, it's okay?
By the way, Mark, they're coming out with a TV show, right?
Yeah, but they use the Fallout 4 assault rifle, so it's ugly, and I have my doubts.
I have doubts too, but anyway, go ahead.
Well, I forgot.
Well, there has NCR. You have a model.
She said it shows NCR, that's what we want, right?
Oh, that's right.
That's the
Yeah,
right selection.
so it's just an older model.
So some of you guys might have an older calculator. It says NCR on the screen.
Yeah.
Just put 80 and then hit the NCR button and then hit 11. We should all get this. Now we know how to interpret this. What does this mean?
God.
13.
Move the decimal 13 times.
That's so many.
Now I'm almost certain none of you would have guessed that the list is that long.
I guess
But if you think about it for a little bit, I got 80 positions and I could put 11 keys wherever I want to. The first 11, the first 10 in the next one, the first 5 in the next, in the middle 5 in the one, that. I mean, my freaking God.
And that's only 80.
My God. Huh? It's only 80. Yeah, exactly. Now at some point, let's try this real quick. Let me see if I can make this guy freak out. Do 600 math probability, NCR. It doesn't matter. 75.
That number represents
Darn
the
it.
length of the list?
Sorry?
The sum there, I'm not the sum, the solution there represents the length of the list, or?
Yes, the length of the list. All right, screw it. I'm not going to waste time with this. At some point, you're going to make something so big, the calculator's just going to go overflow. It's going to be like, send up the little white flag, right?
Wait, how's the length of a
I got
list
it.
represented by a tiny decimal, which is what that is, right?
Times 10 to the 13.
Oh,
So move the decimal 13 times over,
God.
and you get the actual number. Is that okay? You guys with
Moving
me?
the decimal the other way.
So this is, of course, scientific notation, but all scientific notation is move the decimal this many times. That's all it is, right?
Will
You
the
guys are kind of
calculator-
with me.
Will the calculator tell you all those decimals?
Huh?
Will the calculator tell you, like...
No.
So after
no.
that
That's the
last number,
$200
it's all
model.
zeros.
It's all zero.
Yeah, after that 6, it's all zeros.
Oh.
No, not necessarily.
Not
Gotta be
necessarily.
careful. It can only show us so many. Yes.
So this is to just find the amount of lists that will exist, right? Even
The
though
length of the list.
The length. Of
So it's doing what we did by hand. We saw this list was 4.
Yeah.
So we got that number because we could see it. I really want you to buy into what this is doing. So instead of making this crazy ass list that will now, it's known it would take us the rest of our lives. You with me? We can just do it in the calculator. Now real quick, you are never gonna have to look at this number because we're gonna put this thing in all at once. So here's how this works. Let me start over. You get 80 people. I zoomed in a little too much. 80 people. So that's n. Is that cool?
Yep.
Good old n. Same thing the whole way through. Probability left-handed was 0.11. Got it. So p is 0.11. Q is 0.89. So what is always true about p plus q? They have to be 1, 11, right? So if you know one, you know the other one, right?
Yep.
Okay. So now I'm gonna do, in the calculator, I'm gonna put 80, choose 11, I'm gonna keep on going, times 0.11, how many successes do we want?
11.
What did I say? No. I said, did I say 11?
Yeah, you said 11.
Oh, I'm a jackass, alright. I want 11 successes. Alright, just don't like repetitive things because it gets a little weird. How many failures do I want?
69.
Okay, is everybody with me?
Are those to the power of?
Yes.
Wait, why do we want that many successes in?
So the question was, and now of course I've put it down here, probably exactly 11 are lefties. So how many successes do I want? In fact, what did we already figured out? Did we already figure out that it looks like this? Yes, we figured this out, didn't we? We figured out it was going to look like
but
this.
your P is now 11.
P is 0.11, Q is 0.89. So all I'm doing is putting that in. So that's the piece that we already knew. This is P to the 11th, Q to the Q to the 69. I just put in what P and Q are, yes? And of course, the one number we were missing that we could get easy earlier was this 4, which is the length of the list. I don't want to make the list. I don't want it. So then I made the calculator tell us. So in the calculator, this is going to be, and watch how this tells the story. I got 80 people. I want to choose 11. Now go with me here. If you have the newer calculator like this, you got to be really careful. Where am I currently? Am I down or am I on the normal?
Down.
I'm down. So I got to hit the over arrow to come back up. Then keep going. So I got 80 people. I want to choose 11 of them. So how many successes do I want?
0.11 up.
I want 11 of them. Of course, hit the over arrow again because I got to come back down. Times 0.89. How many of those do I want?
69.
69. So I get the total up to 80. Kabam. So, real quick, do you guys understand? This piece is going to be stupid small. Do you understand that?
Mm-hmm.
Does everybody really understand? Like 0.11. 0.1 squared is 0.01. So 0.11 to the 11th power, stupid small, times stupid small, times insanely big becomes normal. They kind of average each other out. So I never have to look at the insanely big number. I never have to look at the insanely small number. I just let the calculator do it all for me, and bam, there comes out the nice. You guys kind of with me?
And then you can
And again, 80 people, choose 11 to be successes. So how many successes do I want? 11. How many failures do I want? 69. The rest. So what must be true about these two numbers, the exponents?
They add up to
They always add up to be the total number, yes? Because either you're one thing or you're the other.
How do you do exponents on this one?
Oh, you're to the button right there.
right under clear.
That's your to the button.
Yeah, so
So let me do this one more time. So 80, math, probability, choose, 11. Hit the over arrow, times 0.11 to the 11th. And now I'm up top here, right? So I better hit the over arrow to come back down. Or else I'm still going to be in the exponent for the rest of it. I don't want to be up there. How you doing? What's the matter?
I don't have it.
well, you don't have.
What?
It just says point 11.
Oh yeah, you do. Oh yeah, you got the. Yeah, you don't have to worry about the up and down bullshit. Yeah, you're fine. 0.11 to the. There's your to the
I've
button.
been hitting that one.
Ah, okay, okay. Yeah, again, some of you guys, you don't have the up and down. You have the older calculator that's just all, and that's kind of nice because then you don't have to remember to come back up or come back down. It's all one line, which is kind of nice. I don't know if you guys are with me. Let me see if I can force this one to do that. All right, let me see what this did. 80, math, probability, choose. Yeah, there we go. All right, some of you guys have this. So it would look just like this. There you go. Is that alright? That's actually kind of nice, to be honest, because then you don't have to remember to hit the over arrow to come back down and come back up. But at the same time, that's really weird to look at. Do you agree?
Yeah.
The other way is nice because it makes it look more like what it would be. In fact, it's called math print. Get out of there. And it would make it look like that. It would make it look more like what it would look like if I wrote it down on a piece of paper.
Do you know what all the buttons do?
A lot of them. All of them? No. Okay. So what does that mean? What did we just figure out?
Well, that was my question.
That's my question
What was
now.
the final thing?
Too bad. I beat you
telling
to it.
us? Because 80, we're choosing 11, but then we want 11.
What was the
successive.
question that got me going on this whole thing?
How many?
The probability that exactly 11 are left-handed. So out of any group of 80 Americans, the probability that exactly 11 of them are left-handed is what we just got. 0.0963. Yeah, rounding up, right? 0.0963, 9.63%, almost 10%.
Is
You
it
guys
free?
kind of with me, huh?
Is it free?
Yep. It's my story. I'm not good with numbers. Okay, alright. So let's do another problem. Fresh. Let's say that the probability that somebody likes coconut. I don't like coconut. Probably somebody likes coconut. What do you guys think? How many people like coconut here?
53.
53? Anybody like coconut? I'm gonna put my hand down. Wow, it's not very many. Interesting.
Oh, how people like coconut? No.
Yeah, I remember being a kid, my grandma got me a candy bar. I bit in that sucker.
Almond Joys?
Oh, wait.
I was like, what is this? So I nibbled the chocolate off the outside.
Hey, Professor, the taste or the consistency?
I hate coconut. I hate the taste.
It's great for your skin.
I'm sorry, if you like coconut, great, you can have all mine. So let's say that probably someone likes coconut, let's say it's 47%. Too bad, huh? So it's probably somebody who does not like coconut? 53%. So let's say that I pick 20 people at random. What's the probability that I get exactly? What do you got, Jeff? I don't know. 7 that like coconut. Sorry, there's one. Try to. Whoa, Jesus. There you go. Okay. Try to set that up. I'll catch up to you. Well, shoot. I was gonna let us out. Well, we're still gonna get out early. That's right. So just because, can somebody tell me what N is?
20?
20.
No, yeah.
Yeah. What's P?
0.47.
0.47. What's Q?
0.53.
I'm going to introduce a new variable. The number of successes that I want, we'll call that X. What's that? How many successes do I want?
7.
7, yeah. Right. Try to set that formula up, and then I'll catch up to you. Rub. There it is. Oh yeah, that too, yeah. So you guys have TVs everywhere? Knowing me, if I was a student, I might just turn one of the chairs around the back and just stare at that TV. If somebody was doing everything up on the projectors. Alright guys, how does this get set up?
20, choose 7.
20, choose 7. Somebody else tell me the next step. Times what? Huh? Yeah? 0.47. How many of those do we want? 7. It's a little repetitive, but that's fine, right? 20, choose 7 successes. So I want 7 successes.
13 failures.
Good. 13 failures.
0.53.
Where
Good
did
guess.
13 come from?
This one?
Yeah,
If your agree was 7, correct?
yeah.
And there's 20 total people. Yeah. So remember, these two exponents always have to add it to be the total number. Right? All right.
What, 1023?
You guys get 1023?
Yes.
Okay. Crowdsource that. I'll be nice and lazy. So, in general, what is this equation then? What was the 20? What variable?
Total.
How many people?
Yeah, so that's n, correct?
Yep.
C, and then what was the 7?
X.
X, the number of successes. You with me? This was P to the
X.
X. And this is, now here's the weird part, Q to the, how did we get this number?
Subtract
Subtract X minus
7,
n.
or yeah.
20 minus
N minus X.
There it is, n minus x. Total minus part. The formula looks worse than the actual thing was. Do you agree? Of course it does, because that looks weird, but this is just the rest. If there's x here, there's the rest there. Does that make any sense at all? Okay. I like this because, again, I know, I like this because it's math, so that's the problem. That is called a, and by the way, I haven't given this a name yet. How many possible outcomes were we assuming there were for this problem?
7.
No.
Oh, tons.
Nope. 2. Either you like coconut or you don't. So for an individual person,
Oh, yeah.
there's 2
There's
outcomes,
2.
correct?
But for 20 people, there's a lot.
Either each one likes it or they don't. So there's only 2 outcomes. So we call these binomial probabilities. Bi for 2, right? Remember binomial from algebra was a polynomial with 2 terms? Or I could just say bicycle has 2 wheels, right? Binomial, 2 terms, 2 possible outcomes. You with me?
Mhm.
If I roll a die, is that binomial?
No.
Could it be binomial? Yeah, I could say I'm looking for 5, which means a 5 would be a success,
Oh, and everything else.
and not a 5 would be a failure, yes? So everything could be made into a binomial
You could do
probability.
odd, even on that same guy.
Huh?
You do
Odd and even, sure. Yeah. All right, so let me give you this. Let me just give this to you, and then we'll see what happens. Yeah.
You gave me 1.
Oh.
I don't know why I did that, sorry.
Should've just handed it one more.
Yep, there we go, fixed it.
Yay, okay. So, we'll do this next time. Right, so we'll step through this next time. You can try it out on your own if you want to. You should definitely be able to start 4-3 homework.
This is better than probability.
So we
Okay.
Can, we can start.
It's
part of
more
this.
specific, right?
We can
Chapter
start-
3 was like wide ranging.
Like, this is like specific.
Yes, that's what I mean. So chapter 3 was all of probability. This is one little
A little thing.
use of it, yeah.
You're saying we can start.
Don't forget your IDs. Yeah, I'll see you next time. We'll do this next time. Sorry. Are you still there, hopefully?
There you go.